Hello, in this video I will show you Tutuca Stack Agent, a full stack domain specific live agent. But before explaining what that means, let me tell it to create a temperature converter for Celsius, Fahrenheit, and Kelvin. So Tutuca Agent is a full stack domain specific live agent. By full stack, I mean that you can create both the front end and the back end in the same agent in the same session. Domain specific because the stack is specific to the Tutuca library in the front end and Val Town mock that runs in a service worker in the back end. So the agent is tailored to the tools and the skills, and the UI is tailored to this particular stack. So it's domain specific, and with that we get some benefits. And by live agent, I mean that the agent runs in the browser in the same runtime where the application is running. So it can do things like rewrite the component and see the UI preview, see the instance and component declarations, query the live DOM, do selectors, compute the styles, check boundary rects, or like what you would do with Playwright. Read handlers that run with before and after state, evaluate code in the same running instance as the preview is running, take a screenshot and play around with it, simulate clicks and reset it when it breaks. The screenshots are taken by providing permissions for image capture using WebRTC, and there's a tool that the agent can use to take the screenshot. So yeah, just now the agent finished creating the temperature converter. Here we have the preview, which is completely interactive, and here we have the transcript of what it happens. I asked it to create it. I set the title and the session info. It listed the skills and it loaded the Tutuca framework skill, Margau UI, which is the UI library that is a port of Daisy UI 2.4. Load some skill sections, wrote the first version of the component. And here we take ideas from aspect-oriented programming. So you can register tools to run before or after another tool. And this way you can validate arguments, provide feedback, or after it runs, for example, after write component runs, it can lint and run the tests and provide feedbacks if there's any error. So it auto-corrects. You don't have to prompt to fix stuff that is obvious. Then searches the skills some more, read the component, and wrote it again. Tried to take a screenshot. I didn't give it access to the screen, so it failed probably. Check the component CSS, render it again. It can call a tool to render the component in a particular state and get the HTML and the CSS for that state. So it can iterate on how it should look in quotes without looking at the screen. And it finished and it works. But it's not only a preview that you have and the agent has, it also has access to storybooks. So it can create different instantiations of the component in different states. For example, here, freezing point, boiling point, absolute zero, and check by inspecting the examples that they are rendering correctly. We can also inspect the instance. Let's see. So I changed Celsius to 10, and here I can see that Celsius is a string, the Fahrenheit is a string, and Kelvin is a string. This is the instance inspector. This is the component inspector. So the component is a temperature converter. It has 3 fields that are text, and it has 3 input handlers, and it has 1 view, which is main. It can also write tests and run them. This is the output of the glitter, which is clean now. It also shows the activity log that everything we can see, the agent can see by itself using tools. So I interacted with the UI and I can see the event, which handler was called, the state before and the state after. So the last one I did, there was an input event. It called update from Celsius. Celsius was 0 before and after it's 10. And of course we can see this, the source. The source is 100 lines in Tutuca, which is some utility functions, the component, the view, and the examples for the storybook and the tests. So yeah, this is the component part, the UI part. Let's go to the Eval, and let's later come back here. The Val part is the backend part, so I will ask it to create a CRUD Val to manage nodes, title, body, tags, created that, updated that, and deleted that. It's going to list the skills. In this case, it has different skills and different tools tailored to the backend. And the backend can't see the front end, but the front end can see the backend because it's useful when doing iteration. So it's showing details about testing, SQLite, HTTP platform. The backend part is a subset of Val Town implemented as in-memory like mock running as a service worker right in the browser. So from the perspective of the agent, it looks as if it was interacting with Val Town, and so it can do everything live. And for example, it can create code and run it, do HTTP requests, run SQL queries, inspect the state of the database. Also, it can check the logs outputs. So if everything goes well, now it wrote a val called nodes API.http, and now it's testing it. Let's see. So yeah, it's testing to test past. Now it's creating sample HTTP requests, presetting the state, running a SQLite sample. So here we can see the code. It's pretty simple, like some validation, read, handler. And we can see here some sample requests we can run. We can also run some sample queries. There's a note there. We don't have blobs here. If there was some console out, we will see it here. We can also run the tests. It has 2 tests. And something else, let's go before to the component. I will create a new component and create a UI for the nodes val. And something interesting also is how you provide context to the agent. When you are using a coding agent in a terminal interface or one that is like centered around text and files, when you want to like refer to something about your application, you usually have to like either copy and paste or describe the thing or provide a path or something. Here we are in a graphical user interface, and so we can do more than that. In this case, when you want to like provide context by pointing at the thing for the agent, you can actually like point at the thing. So if you go to Storybook here, you can see that there's an attach icon. I will click it later because now it's working. It will get, oh, it's not going to send. So if I attach this example, it says here's an attachment of the node workspace and which example it is, and we can see like what is the context of the thing I'm referring to. If I go to tests, I can attach a test run. If I had lint errors, I can attach lint warnings or errors. If I can attach an activity. So for example, in the test, it tells which test was and if it passed or not, and in which line it was defined, and the activity is the whole activity information we are seeing. And next we have a link, so we can attach it before it goes away. And for source code, we can attach a selection. So if we select something, we can attach it, and it will tell it the text and the line range or the like character range. So now we can say something, and it will have all this context available for to work with without us having to like describe it or like wave our hands and make it work. So yeah, let's hope this finishes soon and it one-shots it, so we don't have to go over it for a while. And the last thing I wanted to mention is there's this this other idea I explored here, which is most agents either work, like the data structure or the state they work with is the LLM transcript, so the JSON array of JSON objects that are specific to the agent they are working with, and that's all they can see and express. Some others well, I forgot the name. Well, there are some that have like a abstract transcript format that is the only one the agent uses, and then when it has like is working with a particular LLM, in this case I'm using GPT 5.6 Sol, it basically lowers it into that particular dialect, but the agent works with this common data structure. That means that you can switch agents and it will still work. What I explored is to work with a even higher level representation based on Hypermedia. So you have like request response with headers and with multi-part bodies and content types and URIs. And then the agent can express really like complex and advanced state and keep it in the transcript. That helps it to project it into the UI. And then it lowers it itself because it has knowledge of what is putting into those data structures into like a shared lower level transcript, which is the one that the framework automatically lowers into the wire format, which is the format for the specific LLM being used. And so this is like an idea of modeling the agent state and the transcript as a hypermedia and not like as an array of JSON objects. And let's see if it works. Hopefully it like one shots. My mouse is behaving weirdly now. So there are 0 nodes. Let's see if it works. Like create first node. Let's copy what it says. Like the UI looks nice. Let's see if it works. It doesn't. I could iterate here, but you can imagine that the integration works. And let's see. I will do an overview and let's see if it fixes it. And let's see what it does. So yeah, to summarize, Tutuca Stack Agent is a full stack domain-specific live agent that runs completely in the browser, implemented in Tutuca itself. The only thing that doesn't run in the browser is a proxy for the LLM requests because they can't run in the browser. It has no like low-level read-write bash tools. It has no file system access or anything. Everything is a domain-specific tool, and it takes ideas from object-oriented programming to like run tools before or after other tools. Explore the idea of attachments as things you can point at, and they are added to the context. And it models the agent transcript as a hypermedia instead of an array of low-level JSON objects. And finally, I can go over the tool directory. I asked the agent to create a tool directory of the tools it has access to. So like to reference skills, it can list skills, show skill details, load skill files, and grab skill files. I say files here because like usually skills are implemented that way, but in this case, so now it's, you can see here something I will mention later. It's testing the component, linting it, and it's driving the component. So it's basically like programmatically using the component. And let's see if this works now. Last chance to work. Yeah, now it works. I have a node, I can see it, I can delete it, and delete. Yeah, delete works. So now we have our node taking app implemented. Let's go finally to the tool directory. So skills, since all coding agents have like the concept of skills and they are like modeled like folders with files. I say files here, but there are no files. They are loaded into like a virtual file system, and that is a data structure in memory. So we have session component management. You can set session information, metadata. You can list the components. You can read other components. You can only write your component, and you can show component docs. This is documentation that is automatically generated based on the component definition. You can verify things at runtime. You can link the component test, run the tests, render the component, and get the HTML. Drive the component that we saw. It can like dispatch messages, inputs, and stuff like that, and see the final state. It can look at the final generated CSS because the Tutuca agent compiles Daisy UI and Tailwind in the browser, so it can see what CSS is generated to debug issues with like the UI. It can live preview. You can take a screenshot. You can reload. You can query the DOM. It can eval JavaScript in the same context as the preview, and you can read the activity. And for Val Town, it can list vals, read them, run HTTP requests, create examples, list them, create the SQLite query examples, run them, run queries, list blobs, and read the console output. And it can also like show data and ask the user. So yeah, this is Tutuca Stack Agent, and I think it explores some interesting ideas in the space of live coding agents. If you have any question, just comment here in the video or contact me on social media. Bye.